All right, so here we are zipping along now in part 3, and now we're going to add EIGRP to what we've already done so far in parts 1 and part 2. So let's go back to our original requirements here. I'll put my topology back here and here. So we know that everything's supposed to be in one autonomous system. It was not specified what that autonomous system should be, so it's up to you. I'm just going to use EIGRP Autonomous System 100, but you can choose any number that you wish. And we also know that EIGRP is supposed to be configured on all of these devices, adding every single link into the process. Okay, so let's go ahead and do that. So let's start up everything. Let's open it up once again in Secure CRT. All right, let's start with router 1. Config T, router EIGRP 100. Now at this point, here's a little shortcut. The CCNA doesn't necessarily expect you to know how to do this, and they probably wouldn't want you to do this on any simulations. But if you desire to have every single interface in your router in the EIGRP protocol, you can simply type network 0000, and that covers all of them at once. But for the purposes of the CCNA routing and switching exam, they're going to want you to be a little bit more specific than that. So we're going to use the actual explicit networks along with wildcard masks. All right, and that completes our EIGRP configuration in router 1. All right, so we've saved our configuration there. So we can go ahead and get rid of that guy, get rid of his window. Now where are we right here? Which router is this? This is router 4. Okay, so we'll go ahead and do the same thing. Router EIGRP 100, network 44.44.44.0. That covers our loopback. Network 2.4.2.0 and network 3.4.3.0. And save our configuration. And show IP protocol can verify that EIGRP is configured and that has been configured on the correct networks for this particular device. All right, so save it. Get rid of router 4. And now who do we have? Router 3. Okay, router EIGRP 100. Now, in this particular router, one of the things that we were asked to do was to use the built-in capabilities of Wireshark built into GNS3 so we could actually capture some packets and see what's going on. And I would prefer to do that across the fast Ethernet links. That way we can also see the multicast addresses that are used and the MAC addresses and all that good stuff. And we wouldn't see that stuff if we do our packet captures on the serial interfaces. So in this particular case, here's what I'm going to do. I'm going to go ahead and complete the configuration between router 1 and router 3. I will enable this link in EIGRP so the neighborship will come up. But before I add this link into the, I'm going to go ahead and turn on Wireshark on this interface, which I think is fast Ethernet 0/1 in router 3. And then we'll see that when I add EIGRP to this link, we'll actually be able to capture the packets as the whole neighbor relationship is built and as the EIGRP updates are exchanged. So let's go ahead on router 3 here and add in the command to add EIGRP into the link connecting to router 1. All right, we should see that neighborship come up pretty quickly. There we go. All right, and now before I do the final stage of this, let's go back to our GNS3 topology. And I'm going to right-click and select Capture. And that will enable me to start Wireshark. Now when I do that, it's going to ask me, which interface do you want to capture on? In this particular case, it's defaulting to the one I actually did want, fast Ethernet 0/1. That's good. So now I'll just hit OK, and Wireshark will come up immediately and start capturing packets. All right, so now let's go to router 3 and finish off our configuration. Network 3.4.3.0, 000.255. Save our memory. And we can see that already the EIGRP neighbor relationship was built. So we can go ahead and go back to Wireshark and stop capturing, so we don't need to anymore. There we go. Now, if there were other routers on this link, for example, if there were 3 or 4 routers or something, I might say, well, I only want to see the EIGRP packets that were either transmitted from or received by router 3. So let's imagine there were 2 or 3 other, maybe this link is connected to a hub or a switch or something. I say, oh, I don't want to see all their packets going back and forth. I just want to see the ones going to or coming from router 3. So that involves creating actually a Wireshark filter. So here within the upper left corner of Wireshark is where I'm going to create that filter. It's just ip.addr and then equals, and then the IP address. In this case is 3.4.3.3. All right, and so now this will show me, this will filter out everything and only show me packets where 3.4.3.3 was either in the source or the destination, since I didn't specify that. And so we can see here's the exchange of hellos between router 3, and now once the link comes up, here is an update that goes across. So let's go back to the hello first. We can open that up and see some pretty good stuff. You can see here that it's using the 224.0.0.10 as the destination and its own IP address as the source. And if we scroll, and also we can see that the IP protocol is protocol 88. That's the protocol reserved for EIGRP. This is all stuff you could be potentially tested on for the CCNA. And then if we scroll down to the actual body of the EIGRP packet, right behind the IP header, we can see all this good stuff. So we can see the operational code is hello. This is a hello. And in the hello, the CCNA is going to expect you to know what is in the hello and what parameters have to match and what parameters don't necessarily have to match. Well, we know the autonomous system numbers in there. That has to match. And we also know that under the parameters field, what's called the K values have to match. And we see all that right here. All right, so let's go ahead and shut down Wireshark. We don't need that anymore. And before we exit out of this video, let's make sure at this point, router 1 should know about, actually router 3. Router 3 should know about everything. He should know about the loopback of router 1 and the loopback of router 4. Show IP route. And we can see he does. And furthermore, at this point, we should have end-to-end reachability. So if I close out this, and now here we are at router 2. Well, we don't really care about router 2 anymore. He should be all good to go. Let's just make sure that he's configured appropriately. Nope, router 2 doesn't have any configuration for EIGRP. Okay, so router 2 is done. So now at this point, if we go into router 1, just double clicking on him, and do show IP route, issue that command, we can see that router 1 has learned about router 4's loopback. And we should be able to ping it. And we can. And we can also see that as far as that loopback is concerned, the path that's been learned, or I should say the preferred path, is fast Ethernet 0/0, which makes sense because that path is faster than the serial link on top. Now that leads us to ask the question, you might be asked in the CCNA, how would you discover all of the possible paths that a router has learned to a particular destination network? Well, you should know the command show IP EIGRP topology, which gives you a high-level sort of summary view. And looking at this, you might initially think, oh, well, router 1 has only learned about the 44 network via the fast Ethernet path. Something must be wrong because why didn't he also learn it about the serial link? Even though that might not be the link he's actually using in his routing table, it should still be in here, right? Remember, this particular command only shows you your successors and feasible successors. Now, if you don't know what those terms are, better go look them up, because that's something the CCNA routing and switching exam is going to expect you to know what those terms are. So this only shows you successors and feasible successors. There's a possibility that you could learn of an alternate path to a route that doesn't meet either one of those conditions. It's not a successor or a feasible successor. Why? Well, if an incoming route comes into you and it does not meet the feasibility condition, which is the condition that EIGRP uses to try to detect routing loops, if it does not meet the feasibility condition, it will not be classified as either a successor or a feasible successor. So how can we tell in our topology table if we actually have learned about this route via the serial link, but because it came in and the metric was so horrible, it was considered as a possible loop and it did not meet the feasibility condition? Well, here's how we can tell. We can use that exact same command we just used, but with the keyword of all-links. And now we can see, as far as the 44 network is concerned, yes, the fast Ethernet 00 is the successor, but here it is down here. And wow, why didn't this be considered? Well, look at this. Right now, our feasible distance, our total distance for the best, fastest path is 435,200. Well, our neighbor downstairs on the serial link, he advertised a path of a little bit of over 2 million as the metric. That does not meet the feasibility condition. And if you want to know more about the feasibility condition, you definitely want to research that, because that is also a CCNA routing and switching level topic. So at this point, that concludes this particular section of the video where we've done our basic EIGRP configuration. So stay tuned for the next videos coming up to add the authentication element into this. And then lastly, we're going to manipulate EIGRP so that it actually prefers that slower path on the top.